Hey there guys, and welcome back. So, as the thumbnail says, this is a bit of a last minute stream in several sense. First off, I only decided like 15 minutes ago to go ahead and do this stream. Secondly, the flash contest that we're competing in is only, we only have 4 days left, so have till Saturday. And I think it's Saturday morning for me. So not a lot of time to test designs, which means that we got to go kind of quick here. And that also means that I have not given this too much thought. I've done what thinking I can, but we'll see how this works out. So, I looked through to see if anybody else had this design, because frankly, if somebody else had thought of this before and submitted for the Printables contest, then I may not have actually done this stream. I may not have entered, just because, you know, that would give me an excuse, right? It would be, okay, somebody else has done this. They've had more time to refine their design. So, you know, I already said I wasn't going to do these anymore. I wouldn't do these Printables flash contests anymore. I have plenty of excuses, but nobody else had a transforming car on the contest page. So I was like, all right, I guess we're doing this. The itch is too much to bear. I feel like we have to. So, design constraints for this one. What targets do I want to hit for design constraints on this design? First off, I would like to avoid using any hardware. I would like this to be all filaments. Now, for a transforming car, I'm going to attempt to see how well we can do with just flexing plastic. Just make it very thin. Not foil shape, but, you know, a very thin flex point in order to transform it, and see how well that works out. Otherwise, if we need to put actual hinges in, which is how these generally are designed, in that case, I think hopefully we'll be able to get away with using filament instead of bolts inside of the hinge. And again, this is all last minute. I'm trying to do this as best I can, but I do want to try to do it without using hardware. I want this to be 100% 3D printed. Second design constraint, if we can. This one's less of a priority, but if we can, I would like this print in place. That's, you know, it's all getting... These are a lot of asks, all right? So that one may be a bit too far, a bridge too far, but we'll see what happens with it. And the third constraint, well, honestly, the third constraint is just time. I mean, there's no way around it. We just plain don't have time to do 4 or 5 different iterations. So I'm going to try to blow through this as quickly as possible, and we'll figure out. Yeah, I got to get at least some prototypes printed in between tonight and tomorrow when I get back from work. So one of those things. So we're just gonna have to go. Let's see. I guess start with a new component. Makes sense. The question is, so I was actually thinking I might need to start with the wheel just to see how well we can do a print in place wheel here with axle. I guess the other thing I should say is the transforming design is going to be pretty basic. So I recall getting in, you know, Happy Meals, I think it might have been, like super cheap Transformer toys back in the day. Obviously this says transforming car, not transformer, so it's not a transformer, so I can't get copyrighted. That's how that works. I also will not be putting anything that looks like in Decepticon or Autobot insignia on it. But point being is that I have seen in my childhood a lot of super cheap designs. We may end up with something super cheap as our design simply because we're trying to get the heck done. But if we have time, we will make it more advanced. So all that out of the way. What I'm basically thinking, and I'm trying to decide. So the drawing I did for the thumbnail. And I know I'm wasting 5 minutes now when I said we're up against a time constraint and it's already 9 p.m. and I normally start a lot earlier than this. But point being is thumbnail, quick tangent. I did on the Wacom tablet, in case you couldn't tell. Again, still trying to get used to that. I'd like to get proficient with that, but it is wonky. It is weird feeling to draw on that. Not that my ability to draw is too much better. Point being is I'm half tempted to pull up, to plug in rather, the webcam and just draw out what I want to, how I want to do this, but seems like a little too much work at this point. So basically, sides folding in, the arms maybe folding in, maybe not. One of those things. In the cheap ones I had, the arms did not fold in and the legs did not fold in, like at the knees and at the elbows, rather, I should specify. They just kind of flopped up underneath the car body. So we're looking at that as a basis. And then the same thing, the head, just rotating, either rotating down or sliding down. The sliding down is a lot easier, and that back to cheapness. You know, I have seen that in cheaper models. It's just the head slides up and down underneath the car body. So these are the things we're looking at. Again, would like to get fancier, but just plain do not have the time. So that is the design we're going for. Again, may start with the wheels here and go from there. So actually, you know what? I know I just said that, I just went on that whole entire tangent that webcam won't be going on, but it would be really useful to have this drawn out. So guess what? The webcam. And hopefully the webcam doesn't hijack my audio like it did last time. Let me pull up the mixer. And you might see this over here on your screen because it pops up in random places. It did not. Default microphone. That really shouldn't be default microphone. That should be, that's noise suppression, change. Microphone. Always use this one. Please, always use my actual microphone. Alright, cool. And my audio levels are still good, it looks like. Alright, cool. Well, as good as they're going to get at any rate. So, webcam is on. I'll preview that to make sure that it's pointing at the desk. Got to turn the lights on. Preview that. Lights coming on. And then I got to find my sketch pad. Alright, got sketch pad. Oh my goodness, the white balance is terrible. Alright, let's pull you over, go you down. We'll fix the white balance in just a sec. And I know you can't see anything, because, trust me, you don't want to. Video, input, white balance, and as always, where's my hand at? There's my hand. Yeah, I think that's about right. Apply that. And I guess I'm leaving exposure on auto at this point. It doesn't seem to make too much of a difference. So now I'll let you guys see this guy. Close, 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 push live, close the preview window, and off to the races. So grab a pen. For print in place, this is why I want to kind of have a design, right? So I'm thinking top down. If we do wheel, and I'm just going to put a mirror line here because it should just be mirrored over, right? Wheel, door, body, arm. And again, we'll keep it tight, you know, fixed for right now. If we can change that later, we can. And then, I guess, that there. I mean, this may actually be behind this. We'll have to figure this one out. Actually, yeah, the super cheap ones, actually, I think I recall the arm actually being behind the door. But, point being, let's bring this down. Should have another wheel here. Now the question with the wheel actually is, how do we do this print in place? Because if this is the axle right here, which is what I'm thinking, because this is our bend line right here. Again, we're going to attempt to bend this with actually, let me see if I can't change the exposure a little bit to try to make the lines darker. Move this over here so I can see it. Exposure. I guess 7 is the best I got. Okay. So I'll darken up the bend line. So that line will be flexing. This is the mirror line right here. We got another wheel here on a hub. And then the legs. So legs, like head, actually could slide up and down. So the question is, I guess maybe we print them so that they're already extended. And then you push them up after you're done printing. As part of the transform sequence. So maybe that's what we're looking at. Now, the other reason I wanted to draw this is because we also want to look at what is touching the bed. So if this wheel is touching the bed, and this is the wheel, the arm kind of needs to be here, right? Because when we fold the door up, we don't really want to see the arm. So the arm needs to be past that wheel. Which means that's off the ground, which means that the car door itself is probably going to actually have to be parallel with the wheel. That's probably how we'll have to do it. There can be a little gap here, that's no big deal. And then same thing back here, we'll have another wheel, car door, and the legs. So the legs are probably off the ground as well. And that would mean that they would need to be supported because, again, these legs have to get inside. And we don't really want to flip this upside down. See, the other option is to flip it upside down so that the legs are face down, but the wheels I don't think will fit down here. I don't think that will work with the bending. So we'll have to figure out these legs. It's possible that these legs, we could try doing a rail system, right? So we could try doing a rail system that goes like this so that when the legs extend, and they'll actually be down here. And then they'll ride this rail up to get underneath the car. So that's a possibility. So that may be how we do it. So that way everything is on the ground right here. The front end of the car. Obviously, we have the cab of the car like this, right? And then the nose will be up in the air. So we may want to design a car with a natural overhang. So maybe we do a beetle then. That way the overhang is extra sharp. So if we make this a beetle, then we can get away with this overhang right here. So that may be where we're at right now. Sorry, it's late, so my throat is like super hoarse. I mean, I guess not hoarse, just I can feel it's really hollow right now. So I'm trying to hydrate. The head honestly probably can print in place on top of the buggy beetle. And then just one of those things. Just, it's got some overhangs and breaks free. That may work. Alright, so how do we go about actually doing this infusion? Because that does become a little bit difficult with the overhangs. Let's see, let's see, let's see. I would like to, so ideally it gets designed in the flat version. That way I don't have to worry about putting hinges in here. It's just a wee bit awkward, right? Just a wee bit awkward. Alright, let's, I think I will start with the wheels. That kind of makes sense. Wheels. New component. And I'm going to not do textures for right now. We'll come back and texture stuff later. I guess I should say front driver. And this is front driver side somewhere in the world. Let's see, let's see, let's see. We're top down right now, that makes sense. The question of scale does come up. How big do we want this to be? So that's going to be up in the air for the moment. I will leave that up in the air specifically. Let's say 5mm for the hub. And I do want to try to respect the origin to make my life easier. So, let's say, if that's the hub, let's say that is the diameter, so 15. Actually, I kind of want to go a little bit bigger. Yeah, let's do 25 in that case. If this is 25, then we can probably up this to 10. Let's see, 10. I don't think 10 is horrible. Okay, okay, okay. And then we can adjust this. So let me project out. Get this lined up. So if this is 25, let's see, if that's 25, that's the side of my wheels. Yeah, I guess probably about that much distance, so about 50 to center. I think that's what I'm going to call it, 50 to center. One of those things again, we'll figure this out as we go. Project. And then the total car body, or at least between wheels. We are making a bug. So maybe 50 is alright. I mean, they're pretty square, right? Alright, I think I'm gonna live with that for right now, and as always, if we need to come back and change something, we will. Ah, stop it. There we go. Alright, so, quick nonsense wheel. If it's 25, then maybe 10, maybe 15, maybe 12. Let's go 12. Alright, so there's a wheel. Now we can go ahead and mirror components. Select that guy. Mirror components. Actually, both of these guys. There we go. And dun, dun, dun. Dun, 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 dun. So I'm going to do the axle next. I'm trying to figure out how to connect. So the axle is going to come over to the body. So the axle will come straight off the bed and hit the body, which is going to have an overhang, but I'm going to droop it off this way. So I'm trying to figure out whether or not it's best to use a loft to make the body. And I think it is. The question is how much of the body I make a loft for. Let's see, because we need the center part of the body to be its own thing so that we have a hinge right here. And the center part of here, if we're making a buggy, should be extra domed. Which is honestly not great. We actually may be doing this the other way around. We may be better off doming it this way, doming it up, and printing it face down. That way any overhangs we have are on the underneath. That makes sense to me. So actually, let me really quick rename these. This is passenger, front passenger side. And I do want to keep the mirror in here just for reference sake. Rename, there we go. Back, passenger side. Rename. Driver side. Okay. All the paperwork's taken care of. Let's go back to, or let's create the body now. The main body. Or I guess I should say cab. Cab is probably the, well, no, it's more the main body because I'm going to do the engine too. So I think, and this is what I was thinking it may be easier to do this. Now the trick here is that the side panel, so I'm going to go halfway down the door is what it's going to end up doing, right? This is tricky. So I'm struggling to keep it print in place right, is what's happening here. If it was not print in place, this would be a lot easier. But. Actually, at this point, because if I flip it around, if I flip it and print it on this side, now the arms can't be printed above like this, because the arms need to be on the inside. So this may not be print in place. This may not be print in place at this point. Yeah, I don't think it is at this point. Okay. So if this is not print in place, then these wheels we can go ahead and redesign because everything will just be printed separately. I wanted to do it print in place because that'd be freaking cool. But if you imagine, so basically right now, if we have it like this, then the buggy body, in case you couldn't follow what I was saying earlier, has to be printed like this. And it's one of those things, the spline lines aren't going to want to cooperate with me, but you get the idea. Actually, that was supposed to go up there, but... So that is a buggy body, right? That's how a buggy looks. And that has to be parallel with that. So you can see how difficult that is. Now, granted, that is probably a little bit more like this, which helps a lot. But the problem is, the bigger problem, really, is that the overhangs here, like this. Now, if I take this and I spin it upside down, which is what I was about to do, now the arms, in order to fold underneath the car in a print in place situation, actually, you know what? We could print the wheels on top of the arms, couldn't we? Okay, this is more doable. Now I'm talking through it. It's more doable. So let's get this buggy body in. Let me pull up a quick picture just to make sure I can have some reference. VW buggy. Alright, not buggy. Oh, Beetle. There. I don't know why I keep on calling it buggy. It's... I mean, I know why. Because Punch Buggy, right? Punch Buggy is why I'm calling it a buggy, but... Beetle. Beetle. And actually, no. Looking at the... So the older model, this is obviously the one you think of. Oh, actually, Love Bug is the other reason why, I guess. I was thinking Bug, but... Yeah, alright. The nose does extend out pretty darn far. It's the only thing I was checking. So the nose is, back to this drawing I was doing. The nose is... more like this, right? And then the back end actually comes quite, straight up. But this part right here, the front end, is a lot of overhang. Again, if we're printing in that direction. So, let me drag this over here. Whoops. Right. So if, so we're going to have a hinge here, body here, and actually the placement of these wheels probably has to come out a bit because I'll go halfway up the doors. Nah, not really halfway up the doors. Okay, we are going to... I know I'm humming and hawing here. It's a rather major decision we got to make at the moment as to how we are going to continue with this. Let's see. Something. Stop it. Stop snapping down. There we go. Control. Control works. Something like... I mean, the nose is a little like this. So there we go. Something. Something like that. Something like that I think looks correct. Then we can have a reasonably straight line up like this. And I'll probably just fillet that back there. Actually, you know what? No, I shouldn't. Not fillet. Maybe like this. A little bit of a slope. Maybe not so much of a slope. Maybe picture the back end. I feel like it's a little bit more like this, but I'm pretty sure I can just fix this by going this and like that. I think that's more or less right. Now it's just a matter of proportions. Drag this back a bit. Drag, whoops, Control Z. Drag this forward, roundabout there for the wheel. Actually, no, it is actually a little far back. Maybe right there is fine. And then the back wheel is like way back here. So do I need to move this wheel back? In theory, actually, I think that wheel is probably the correct proportion for what we got right here. So yeah, I think this wheel does need to move back. So wheels, let's make this 100 then, because I think we need to go maybe 75 because I'm mirroring it. So that should get me close. Can we make up for it just by moving stuff? No, I don't think so. I think we do need to go further. Finish. Alright, cool. And then we can drag the rest of that up. Just drag it forward. And this wheel is round about there, it looks like. So we can drag this back and that back. And I'm not actually editing the sketch right now. Nah, I guess it is more like that. Okay, fair enough. And this guy looks a little wonky. Let's see. Okay, your problem is actually the other guy. So, Control Z, grab this guy. This guy's the problem. Yeah, looks alright. Okay. Now, no. I think I will keep this parallel with that for right now, and if we need to change that, we will. So, hey. Grab this line, delete that, collinear, and connect to that. Okay, but don't do that. And one of these things, I normally like having this stuff better defined, but at the moment, let's see. Okay, so this actually probably needs to come out a little bit like that. And we might want to... I mean, it is a sharp angle, so... At least the one I'm looking at, anyway. Is a pretty sharp angle. Alright, there we go. Yeah, it doesn't quite look right, does it? Maybe... Funny thing is... This is tough. I almost think I should actually delete this point. Delete this line segment and just do a straight line back there is what it almost looks like I should do. Funny thing is that it kind of looks convex to me, but I know that's a straight line, so... Yeah, actually, this is probably more of what I want, right? Just a matter of... Maybe this guy? See, it's something like that. All right. That is enough time on that. So. Now for the harder part. Because all of this is going to extrude flat, and we don't want it flat, so we're going to have to fix that. Let's see. Options are filleting. Or... Can we do a revolve? Can we do some kind of revolve? Yeah, I don't know if it's worth it. Let's just get this extruded really quick. Distance symmetrical is what I'm looking for. Overall, let's call it 25. No, 50. We can go a little bit smaller than that. I'm just trying to get proportions on the cab, and then if I can move the wheels back out again. Maybe around about that for proportions on the cab. And then let's look at this really quick. Yeah, it's not great. Okay, let's try this really quick. Let us try... this. Hopefully this doesn't move my other sketch points. It doesn't. Alright, cool. Let's try this, and then... and instead of that, let me... symmetric... Nah, I guess that's not really gonna work. Okay. It's a complicated shape, you know, doing the nose on this thing. It's not because it's because the hood, the front hood, is a separate piece and it is more rounded than the rest of the body. Like if you look past the if you take the thing off, you can more or less draw a straight line like this across. It's just the curve on the hood adds to it. Maybe we don't worry about that for the half minute. Maybe we leave that alone for right now and come back to it later. So... so this wheel is going to go inside of here. So we need a wheel hub. $25. And actually, yeah, instead of saying 25, we should be able to just tangent off of this because this is the width right here. And then we just got to figure out the placement of this. Get rid of that. Actually, you know what? Funny thing is that that is more or less right. It is around about the 40% mark on this. On this sticking out the bottom. Let's go 5. So there's that. Alright, so that's that. Brosifs. Oh, you got unstuck, that's why. There we go. Yeah, we could probably delete this one, just set that. Reconnect that. Alright, so if we are doing print in place, now the question becomes 3. How exactly do we want to connect everything? Huh? Oh, don't do that. Don't be silly. All right, so I'm thinking ball joints. It's one of those things. If we can do ball joints that way you can snap into, that'd be ideal, right? The arms, let's see, bottom. And we'll just sketch really quick. Stop rotating me. So the arms here, wheels, well, back to the wheels would be here normally. They'd be connected like, let me turn this off, that off. Wheels would be like this normally. So that's the top view of the wheel. And then the arm would in theory be underneath. The arm, the back side of the arm could snap into this axle to keep it up. That's one way we can do this. The axle's gonna ride, the wheel's gonna ride freely on the axle, I think. The arm, actually no, wait. The arm actually, axle into the arm, right? It would be the more natural way of doing it. Which means that, so this is underneath the car right now. The axle going through the arm, attached to the wheel. This swings out. It swings out this way. Now the wheel's back there. So this is the back side of the wheel. Actually, if this is the back side of the wheel, I can just draw a circle. So that's the back side of the wheel with the arm here. And the center axle here. We'll just line this up really quick. Centered on the arm there. So this goes to that. That swings out this way. Here's the car body over here. And maybe the wheel's more like that. Actually, no. The wheel is completely under the car body in the Beetle. So there is that, and then the arm swings out this way. If the arm swings out this way, then the clip mechanism actually needs to be on the inside of the arm right here, because we don't want it to be facing forward when the arm is out. The bigger question is, how are we hinging this in and out? How are we hinging the arm in and out? Especially because if I use a clip mechanism right here, so I guess maybe I gotta give up on that. Or actually, you know what? Maybe the axle runs all the way through this arm. The axle extrudes all the way through this arm, and then the axle itself clips into something here and holds the arm there. Okay, that works. The axle could be square as well to keep it. Does the actual one be square? We'll look at it. The circle here, definitely circle here, but square going through the arm. I was thinking because otherwise this arm, as you can see, if it's on this axle, can droop, and we don't want it drooping. But if it's square inside of the arm, then that's not going to pivot. Although the clip, it only has to be square on the clip. And then the clip can keep the arm from drooping. Female clip on the arm? Maybe we're thinking female clip on the arm. So female clip on the arm, that way it's not as noticeable, question mark. Or a clip at the top. Clip on the shoulder, so a shoulder pad that acts as a clip. Clip up right here. And then maybe one on the fist as well. The fist also goes into a recess. And then the pivoting mechanism again is a question. I mean, I would like a snap-in hinge here. I'm just a little concerned about the integrity of it, is all. I guess maybe build in and find out. Well, it does need to be on the inside, yeah. Okay. Let us project. If I... Oh, hold on, actually. Delete all this first. Finish. Delete this. Let's actually make an arm. New component. Arms. New component. Don't get mad at me, but this is driver side arm. Here's the wheel right here. So, oops. Project. Want all this. Actually, what happens? Yeah, okay. I was gonna say, I don't recall ever being able to bounding box it, but stop it. Okay, so there's the wheel. So we need the arm to at least be here. We can make this any arbitrary amount. It's whatever amount looks good. So let's see, if the wheel's 25, we got the wheel at 25. The arm, does the arm need to be smaller than wheel? No, the arm could be offset from the wheel. So. Actually, let us, in that case, Control Z, come here. Do it from this side. Project out that, okay, and project out that right there. Okay, these are the two things we need. Turn the cap off. Do that. We're gonna want the axle. The axle, I think I said was 10, 12. I think I said 12. Oh no, 12 I think is the side. Let's check. Finish. Come back here. Oh shoot. Deleted. We'll have to redo that. Did not make that part of arms for some reason. Project cab. Try this again. That guy. Huh. Where'd my axle diameter go? Where's my wheels at? Huh. It did not rename it. Finish. I'm not going crazy, am I? Huh. Okay. Weird. Weird. Okay. Yeah, there's still no name spacing. There really should be name spacing in Fusion. I still haven't figured out why there isn't. It doesn't make terribly much sense to me. Give ourselves... let's see. Yeah, honestly, at least 3 millimeters is probably fine. And these are actually both construction lines, and that's what I can tangent up to. For my arm, let's just visually confirm the wheel, that we are in fact below the wheel. We are. This... We're also below the car body, which isn't great. Is not great. Options are using this right here and giving ourselves a little bit of this action. So actually, let's just delete that tangent and collinear that. And then arm thickness. This is the width of the arm. This is the width of the arm. So the arm width. I mean, we have the room, so we may as well start out at 25. And then the next question is, do we add an elbow joint? I don't think we'll add an elbow joint for right now. We'll just make the full arm for right now. So let's just consider the full arm to be 100. We'll see how well that works. And then we have an option here as well about how much space we give at the top. You might expect the wheel to kind of be hanging out here, you know, or here. Either of these two would work, right? So either have the wheel towards the top of the arm or have the arm aligned with the top of the wheel. Let's align the... Actually, let's do this, I guess. We'll do this. We'll try this out for right now. And then we can do that. Okay, cab. And we are doing this from... Actually, finish. At this point, because we're not doing a print in place, these wheels really should be facing up at this point. It's not great, but oh shoot, that's right. Yeah, we kind of screwed up at this point. Actually, I guess what we can do is grab these guys, move these guys down here. Okay, attempt to move these guys down here, and then have Fusion freak out on us. So we'll go here. Please, Fusion? Nope, okay. That's right. We can't because we have the back wheel referenced. So, we can, however... No, we can't because the back wheel's there. Okay. So we're gonna do this the hard way. I'm gonna do bodies because it seemed like on a recent project that I was doing, it seems like when you align bodies, you know how I always complain about Fusion not having an alignment history? It seemed like it was actually remembering my alignment on the project I was doing because I was just doing body. Let's see. Wheel should be aligned with the outside. Okay. So. Oh, don't do that. Don't be ridiculous. Why are you doing that? I do it on the inside, and... There we go. Let's grab the face instead then, if it's gonna give me trouble. Do 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 do. Do 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 do. Okay, cool. So we got those in line now. And fact of the matter is I can now delete all this stuff and project that wheel instead. Tangent. Toss this guy back in here. Three. There we go. Actually, I should keep that in there. Alright. Now, no. We want all that. We want that from here. This is the point of moving those guys in so we can get proper measurements. I'm sorry. Not from there. From there. And then this is going to be the thickness of the arm as opposed to the width. I guess we can make it a little shallower. So it's at 25 right now, right? So we can make it 15. Oh, but we want to be in here. Okay, and then now we need to figure out how this hinges. Dun, dun, dun. Bum, bum, dun, 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 dun. Let's see. I mean, we have problems here, right? The way we're doing this at this point, especially because, well, not especially, but if this was hinged the way I was originally going to do it and this whole entire side opened up, then we'd have no problem, right? This would just flare out if we're keeping it super simple. I decide to not keep it super simple because we're not doing print in place. So, for that reason, I was going to go with a more complicated joint. If I see, I kind of want to this wheel. We were looking at getting this wheel and this guy swung out this way is how we were talking about designing it earlier. The issue is that I don't know what we're attaching to that lets us swing out that way. I'm now considering swinging this arm down along the wheel and then out. The other option is to drop the whole entire thing down and then out and back up. So the bigger issue is I don't know how we fit that in here in the nose of in the front hood. So basically, if this came straight down and then transferred to this side and then came back up and then snapped into something, this, whatever this axle is attached to, snapped into something. But it's one of those things, because it's a not transformer, you don't want to take it apart. So if we could just take it apart, you know, then we just unsnap this, bring it on the outside, and push the axle back up into a snap, and then we'd be golden. There'd be no problems. But because we're not doing that, or because you wouldn't normally do that, because again, a not transformer doesn't have pieces that come apart. It stays as one piece. So I mean, what I'm thinking about is if we can make this work. I'm not actually going to do the sketch here because obviously that's on the outside of the cab, but the axle is here, and then we have this running straight up like this, and then potentially another piece running like this. That's how we would fit it in. So this whole entire mechanism, actually I should probably just delete delete that too. So let me, and then we'll just toss a 30, I guess, right here. So pretend all this lines up, right? Just because I don't feel like redoing it. So this is snapped into something right here. We then snap this out. Yeah, see? So actually, so this right here on actually, let me do this. Ketchup Fusion, slot, maybe on a slot. So this can come forward and pivot down and around. It's not going to let me pivot down and around because this guy. So this comes forward and can do this thing. There you go. So it does that thing. And then it also has to come towards us, right? Pretend like this is a constant length, so it's riding along here. So then it needs to come towards us to get the axle and the arm out, and then come back up, straighten itself out, and reattach just inside. Actually, that might work. So instead of having a slot here, having a shaft here, which something like, we're going to use this slot as an example, but it could be a square, you know, just for the sake of simplicity. A square with a hole there on there. And this shaft running forwards and backwards allows you to come down, come back up, slot in. Yeah. That will work. All right, cool. I think that was at the 1 hour and 10 minute mark, so that was less than 5 minutes to hopefully figure that one out. I think that works. So let's see. Let us see. We'll throw the axle in. New component. Axles. Gonna want that. Gonna want this. Gonna want this. Actually, you know what? Instead of doing that, we will just extrude that and then we'll just offset it. So distance to object, that. And so long as we don't cross the center line, we should be fine. And we don't need much. So let's say... let us say 5 millimeters to be safe. Give ourselves a millimeter on either side. And maybe more. Maybe 8. We can always come back and fix it later. So there's that. And then we need the new component front transformation mechanism. And I guess we will do new component, sliding rod, do this on center, and then we actually can have it run the whole length of the car. That's fine. Do that. And I guess, so the position of it is a little bit arbitrary, I think. In theory, it could actually be right here. Yes, no, maybe? No, it needs to be back a little bit because we need to be able to drop. Well, no, because this arm, so we just need to clear this top part of the arm, because so long as the distance, so long as it drops down far enough that that arm can then swing down. So we're going to unsnap this arm. It's going to be on this axle. It can swing down to clear. So we only need to clear the top part of this, which is actually the same size as the wheel. So we only need to drop this whole entire mechanism down by the wheel height. Or by, I guess, the difference between the top of the wheel and this, which is 25 minus 6. So 19 by 19 millimeters. It's one of those things, we may have a little bit more room than we need, but that's fine. A little bit more swing than we need, like it won't be super tight, but who cares, because it doesn't matter if it's super tight mid-transformation, as long as it locks into place afterwards. So, I'm gonna do this, call this, see, it only, I think it only needs to go down 19. Make this 3 millimeters. Actually, let's make this 5 millimeters. We have the space for it, so we'll make that 5 millimeters. This height right here, we're going to want a reference to the arm. Let's get some constructions in here. Let's turn some of this stuff off now. And I don't think it needs to be any particular height from the arm. I think it can be pretty, actually no, because what we're doing is we're attaching again a square or a slot or something to it, which means that we need that meat around it. So let's prepare for 3. And if that's what we need, then actually so this is a straight line right here, but does it need to be? I don't think it does. So in theory, instead of having an L shape, I think we might be able to get away with slot. Let's just use a slot. Actually, not overall. Slot center to center. Wait. Slot. Not center to center, not center point. There we go. So we might be able to get away with this. I think. I'm thinking of this correctly. In which case... let me delete this stuff, because we don't need this stuff at this point. There we go. Alright, so we probably just want just like a millimeter of clearance then in that case. So we don't bump into anything. Actually, this will never bump into the arm because this is on the outside of the arm. So we don't need clearance on the arm, so maybe just clearance on the inside of the hood. So there is... Oh, I can't tangent against that. Because that's a spline line, I can't tangent off it. Let's see. Should be able to, though, put a point on here. Make it direct... well, don't need that if I'm doing a line anyway, because lines come with points. So do that, and then connect that to that. There we go. Alright. And that needs to be coinkydink on that. And then... What other play do we got? Yeah, so that's the play we got, and it... Okay, maybe this doesn't work. Because... Actually, it could. So you could push in first. So long as we have space on the inside of the cab, you can push it in to get the wheel clear of the wheel hub. You just need 3 millimeters for that. And then rotate down, then rotate out, and then rotate back up. Yeah? The L shape, so the difference between this and the L shape is that the L shape gives me swing, and it's also easier to lock into off this hood, because we need to lock it into something. Or I guess it can lock into the side, can it? Yeah, it can lock into the side of the nose here when it's open, and when it's closed, when it's in car mode, we can just have the arm locked in. The arm can clip in when in car mode, and when not in car mode, this can have some clips here and here, let's say, that connect to, or maybe not here and here, because this is in the wheel well, but maybe right there, that clips onto the inside of the door. And not necessarily round, but could be anything. Boom, 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 boom. All right. Question is how far out we want this, because the further out we get this, back to if we are going to do some kind of clip in here, the more room we have to clip it. So as you can see, as I get closer here, it starts running into the wheel well. So the further away, the more room we got. Although, no, because we do have room for the clip, because the arm is offset by the wheel. So this thickness of the wheel, so we have a full 12 millimeters on the inside of the cab here to work with for a clip. So we probably don't have to worry about hitting the arm, with the arm hitting the side of the clip there. And actually, to that point, the side of the arm could use the same clip as this rod. which is useful. Point being. Okay. So I believe I am on the outside of the car right now. Am I? What is my profile? I don't know what my profile is right now. Oh no, I am on center. Yes, I am on center. Cool. So we are on the correct space. So let's just delete that. We will, if we have the room, then come back in here to edit. May as well just use this as our connection point. Oh, that's funny. Cannot use that as the connection point, huh? Why? Huh. Are you sure about that? .0001? Huh. That's funny. 50101. I wonder why. Huh. Oh, and then it didn't let me do it anyway. 0.1. I wonder what it doesn't like about that. Why doesn't it want me to be able to quinkydink that? It's beyond me. It is beyond me. Okay. Here's our sliding rod. And we should be able to run this the whole length of the car. So symmetric. Or not symmetric. Two-sided. To object. Looks like we're heading this way. We are not heading that way. I don't know why that arrow is blue if we're heading that way. I would think that the blue arrow is the one you're working on. Just my opinion, but my opinion is normally always correct because I always win. So there. Alright. Okay, there's the axle back on. Cool. So there's that. We come back up here to this. New component. Driver's side. Transformation arm. Okay. Go ahead and grab that. Project out that slot that we just did because the slot can just be used. And then grab, actually, you know what? Let's do this for now. Turn that back off. And then project out that face. Not that face. The other face. That face. Okay. And project out the axle here. Actually, that's a good point. That is an excellent point. Okay. This is what we'll do. Control Z, Control Z, Control Z. Z. And we will ad hoc this. Makes more sense. There we go. Face. Face. And turn stuff off. Minimize, minimize, minimize. Select. Turn off. Turn that guy off. No, that guy. Minimize. Turn that off. Okay. And then we can go ahead and just do this manually. 3. Click and tangent. Tangent. There we go. Click and tangent. There we go. Alright, cool. So there is that. That's the full body we need. Turn the... Let's see. I think I need the axle and the arms is how I want to define this. I do want it fully captured. I'm trying to decide on the lock, how we get this on here. It kind of should be snap-on. I haven't done really a ball joint snap-on. I know I said I wanted to use ball joints before, but I have not actually done ball joint snap-ons before, so I'm not sure what requirements are going to be there for getting it to snap on and not fall off. Obviously, we don't have a ball joint right there, but I figured I'd add it on, but. Maybe I don't. Maybe instead we have it kind of snap on as a ring, just to keep our design simple here. Did I miss the center part here? Let's offset this by 1 millimeter, and then minus 3 millimeters, minus 5 millimeters. We gave ourselves 8 millimeters space, so there is that. The wheel is on this side, so this is the back side, so you don't see it. I'm just looking at this back to where do you put the clip. So long if the clip is male on the inside of the body, then this can actually just be a recess. We can just recess this and clip in, which may be the way to go. Otherwise, if we, instead of using a snap clip, which is what I was thinking of, if we use some kind of, because the just a sliding joint is all I was thinking, just a some kind of joining, keyed slot kind of deal. Yeah, maybe we do that. Maybe we do a keyed slot instead. So, we got that. So. Let us come here to the cab now. Go on the inside here. Grab that. So this is going to want to go through both of these guys. So we're going to want to find some place that overlaps these two. And we can always move this back to give us slightly more options. Yeah, I mean, it actually doesn't help. If we start sliding this back, we don't open up too much extra space, so we're probably fine wherever we are at right here. Probably not worth bothering, just because, whoops, we're on the cab right now. So bodies, you can imagine if, let me just do this actually I don't need to do that one. So if we slide it back to here instead, there, tangent. Actually, I shouldn't have done that. I should have done equals that. There we go. Now come back over here. You see how, as I slide sideways here, we don't open up that much more space. It's basically the area underneath this triangle, the smaller triangle that we're opening up. So it's not super a lot of extra space compared to this, what we have right here. So I don't think it's worth moving it right now, just to demonstrate why visually. So we're going to grab a square because that is a stable shape. Could be a hexagon, could be whatever. Square is just simplest. Question is, how do we go about centering this up. I mean, it doesn't necessarily need to be super center, right? Well, let us, just for experimentation's sake, draw this line in here. Nah, that line doesn't help. So I want it in equal distance between these two lines. I want it centered on those two lines, so that's center to this rod, because this rod is kind of more important than the arm. The arm is less important. And then we probably want to make sure we have some meat on it. 3. Yeah, I mean, so actually that is more or less where we're at right now anyway, so. But I'm not sure why I did that. Meant to do this instead. So. Let's make these equal because this is a square. It doesn't necessarily need to be a square, but. So actually, I guess we can. Doesn't matter to me. Let us project out the hub here. Just that we keep that in mind. Yeah, so that hub. We want to stay away from that hub, so it is good that I projected that out. Do that, do that, do that, do that. That. Okay, cool. So this hub, slide back this way, please. Thank you. So we'll go tangent to this hub. That way we have meat there, and that will determine where we're at right now. Okay, cool. Easy, easy, easy. So now, again, this is a male peg, and then we'll plug into the arm. We want to make sure it is long enough to plug into the arm. Do we want to go all the way through the arm? I almost don't think we do. Just because the longer it is, the more we gotta thread through that peg. Or the arm, the connection arm. -10. -5. Let's see what happens there. This will join this guy. So this does actually make this more difficult to print, unfortunately. Again, not wanting to use hardware kind of also meant not wanting to use glue. The rod up here, the sliding rod that we have up here, let me turn it back on. This guy, I was going to make little hoops for it to snap into, so that's not that big of a deal. And obviously we're talking about snapping this onto the axle, so that's easy to assemble. This guy though, if this guy is not part of the body, then it had to be attached somehow, but it's only, unlike the rod, which spans the whole entire thing, right? And is supported on both ends, this is only supported on one end, which is not great. So just sticking it in here loose is asking for trouble. So it kind of needs to be printed as part of the body. All right, we will go ahead and join this for right now and revisit this in a moment. I want to really quick check our motion and make sure that we're actually transforming correctly. So let's get that set up really quick. Wheels. As built joint. That, and this is a revolve. Around. Let me turn the axle off. There we go. Axle. Okay. And then we've got another revolve here. As built joint. Revolve around there. Turn the axle back off. There we go. That's good. Axle. As built. Cool. And then we're done with the axle, so now we need as built joint that on that. There we go. Okay. And then actually, shoot. It needs to be both, right? As built joint, that, yeah, existing. It says may. It says may cause a conflict. It doesn't actually say it will cause a conflict, so. Okay, it does accept both. Alright, cool. So, we first slide this way. Slide this way. -3. 3. All right, never mind. It's causing a conflict. Okay, this is what we can do. We can revolve this instead. As built joint that. Turn the body off. That. This is not a slider. This is a revolve. Okay, cool. Alright, so that can revolve instead. So, first off, slide in. And actually, yeah, it has to slide in enough to clear the peg. So if we made the peg 5 millimeters, or made the peg offset 5 millimeters into the arm, then that's what we need. Then we go down like this. And this guy, the arm. Is that the arm? Where's the axle? Turn the axle back on. I guess that's the arm. Rotates like this. Just needs to clear it. There we go. Okay, and then we rotate out. Not out too far though. So -12. Actually, yeah, we do need to rotate far enough out to. So the peg. Alright, we're going to ignore the peg for right now because the point was that we needed this space to go, the arm to go up into the hub here. So, let's see. Yes, that's the one I wanted. So we needed this. -28, 27. And obviously I did not leave myself enough space there, but I want to see what else we can see here. So this goes back to 0. And now the arm is on the outside. You know, in theory. Again, we can fix that spacing. But the problem is that this needs to swing up and the peg is in the way. So the peg is not going to work. So back to a clip. Can we do an underside clip? Can we do an underside clip? So this goes up above the clip and then rotates back down, is what I'm thinking. That way the arm, because I'm just looking at this here, right? And back to the axle is significantly smaller than this, which means that we can come up to clear the clip and then rotate back down to the center point of this axle and be in the clip. That's the idea. Alright. So we're deleting this because that doesn't work. We're fixing the length of this axle. So this needs to go. Well, actually, this is a combination of this axle and this guy right here. This guy being at 5, I think I actually do like. So we'll keep that guy at 5, so we do need to change the axle. Yeah. So the axle needs to take that 5 into account, plus this wall thickness, which is 3. So that's 5 and 3 is 8, plus some on the end is 2, or 3, plus a little bit of play. Gets us up to like 13, 14. So let's call it 14. Next question is, what is the distance between the start of the axle, which is the outside of the car, and the inside of the axle, which is 41, and our overall distance to make sure that we're within the center point is 80. So we are going to go ahead and up the car width to 85. And it looks like, back to, remember what I said about the body alignment actually having history on it, unlike the component alignment, these wheels would not be in the correct position if that was not the case. However, it does look like, did I not offset the arm to begin with? Okay, yeah, I did not leave a gap between the arm and the wheel before. Okay, that's fine. Again, we did introduce play in here. We did account for some amount of play on that guy, so I am going to modify this rod right quick for printing purposes. This rod is not going to be happy getting printed up and down at 84, or a little less than 84. So it's 84 minus 6 is it's late 78 millimeters. So printing a rod 78 millimeters straight up in the air is a bit sketchy. So alright, not that much then. We will print it laying down on the bed. It doesn't have to be perfectly round. It really shouldn't affect it too much if it's not perfectly round, which is why we're allowed to get away with this. So, let's see. Let us see. Is there any benefit to keying this to the rod now that we have a D shaft? Now that we have a D shaft, we could in theory key this to the D shaft. That would allow us to transform both the arms at the same time, but I don't know that that's actually a benefit, so we won't. This is complaining because it no longer has the profile, so we'll go ahead and fix that. Control C, do this, and then tangent that, and then turn that to that, and set our 3mm here, and what else are we missing? Or are you still unconstrained? Oh, am I not? Doesn't that say concentric? I'm pretty sure that says concentric. Concentric. Don't know what you do in Fusion, but evidently it's the good stuff. There we go. Okay. Alright. Now. No. I think I'm going to leave this like this for tonight. Print out the maybe the front hood of the car, so just cut it right here and then print out all this and make sure that it's working the way I think it's working. Actually, you know what? In that case, I do also want to put the cups in there to hold the rod. That would make sense. So let's go ahead and design those really quick. Let's see, we can put that, yeah, we'll put that in cab. Obnoxiously, as you may have noticed, I decided to abandon the naming of all the important stuff, which is unfortunate. So I'm going to have to find my own time to do that, to go back through and name literally everything. Again, not ideal, but choices were made tonight. 3mm. Actually, I think I will take this straight up. And so that's a bit far to push this rod down into. Maybe we cut it down by a little bit. 2mm. Okay. So there's that. Body. From object. -3. Not -3, just 3. 4. I guess 4. And then the only tricky part here is, actually, you know what? How difficult is this? Do I have an inside left car passenger side? I do. So back to printing with a minimal amount of supports. Actually, I guess turn that one back on. Tangent, tangent. This vertically straight to that. Yeah, actually, I guess I should, let's turn the body off really quick. Guess I should leave these guys as solid. Finish, body, loft. That is not loft, that is loft. Do it the other way because I gotta select multiple profiles. There we go, body, body, body. And I'm lost. Help me, I'm lost. There we go. This is the angle I wanted to see. Thank you. And that's a join. Alright, now we can just figure out a distance here, and I could do math, or I could just say, it looks good enough. And I think I'm going to go with, looks good enough. So let's go ahead and mirror these two guys. Not components, features. Those two guys across the center line. Let's see how that worked. That worked well. The rod, I think, can sneak in past this, so I think we'll be fine there. The inside of this hood is going to have bad bridging, because that is obviously pretty terrible. But because it's on the inside, I don't think I'm going to worry about it. So. The only thing left before I print the test pieces, what happened here? Huh? Is that my... That's not my mirror, right? Wait, which side did I... No, Huh? Huh? Weird. Okay. The last thing I need to do before we print the test pieces is just add my offsets. And I want this stuff to actually be pretty sloppy, so let's go 0.4. Yeah, maybe 0.5 even. And I like new offsets instead. 0.5. Minus 0.5. Actually, no. Minus 0.5 is ridiculous. Alright, never mind. Minus 0.4. 3. Where's my axle at? 3 should be fine. 3 should be fine. And actually, that's right. I do need... axle. I should have put something on the outside here to make sure that we don't fall off. Finish. Let me come back here and do this so that we are early on in the timeline. And just like 2, maybe 1 even. Nah, 1 is too little. 2. Join. Okay, cool. Alright, so we got 1 offset so far. The arms need offsets. Let's hop back up here to get the end again. This is because I changed the front side of the axle, which we took off of last time. Relink that to this one instead. Finish. And back to what we're doing. So take the wheels off and the axles off. Minus 0.4 because again, or 0.3. I want this to be really sloppy. Done with the arms. Let's see. So for printing purposes, I probably should open these guys up a little bit. So before we mirror that, over here please, thank y'all. Just hit this guy. Oops, not extrude, wrong one. 0.1. Just to be on the safe side. And then mirror that one as well. Whoops, stop. Mirror that one as well. Okay. So there's that. And then the transformation mechanism. We want that and that, minus 0.3, so they're loose. And that is everything. Okay, cool. So now I can print out the test pieces for tomorrow morning, and if tomorrow morning I decide that something desperately needs to get fixed really quick, I can print another set of test pieces or replacement pieces while I'm at work. And therefore tomorrow's Wednesday, so yeah, tomorrow Wednesday I actually will stream early tomorrow. That way I can do test pieces again afterwards. So I guess plan on being back here. Let's see. Yeah, I shouldn't have anything going on tomorrow after work. So I guess I'll plan for either a 6:30 or a 7. I'll see whether or not anything comes up. Let's just call it 7. 7 should be plenty safe. So you guys can expect to see me again at 7 p.m. tomorrow for the follow-up stream with news as to how horribly all this went. So until then, guys, thank you guys for watching if you have been, and I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world. And I will catch you next time.